Now let's imagine that we have two rays in opposite directions sharing the same endpoint. In this particular case, it looks like we have a line with a point somewhere in the middle. However, in geometry we call this a straight angle. Straight angle measures 180 degrees, and the point where the angle rotates is called the vertex of the angle. Remember that a straight angle comes from slicing a circle in two. Since a circle has 360 degrees, then half of the circle is 180 degrees. Okay, if we now close the vertex of the angle to make the angle smaller, we close it until it is half the size of the straight angle. We get a 90-degree angle. 90-degree angles are called right angles, which conforms with a typical square corner you find everywhere, like in rooms, windows, and sidewalks. Now, lines or segments that meet at right angles are said to be perpendicular to each other. And angles that are greater than 90 degrees are called obtuse, which means dull. And angles less than 90 degrees are called acute, which means sharp. Like segments, angles may be bisected. The result of bisecting an angle is that you get two smaller equal angles. Go to chapter 10 to learn how to bisect an angle graphically. Angles that have the same measurement are said to be congruent. So if I say angle B equals 40 degrees and angle B equals angle E, then angle E is of course also 40 degrees, and the angles are congruent. Angles also have transitive properties. For example, if I say that angle 1 equals angle 2 and that angle 2 equals angle 3, then angle 1 and angle 3 are also equal. Angles could be part of a linear pair. They could also be vertical when they are back to back, as they form part of an intersection. They could also be called adjacent or side by side, or opposite, like when they form part of a triangle or a quadrilateral. Let's talk now about supplementary and complementary angles. If you are given a linear pair, that is, a pair of angles on a straight line where three rays share the same starting point, then the two angles formed are called supplementary angles. Therefore, all supplementary angles add up to 180 degrees. Now, if I find that two angles are supplementary to the same angle, then the two original angles must be congruent. For example, if angle 1 is 130 degrees, then angle 2 must be 50 degrees, because they are a linear pair. Now, because angle 3 is supplementary to angle 1, then angle 3 must be equal to angle 2, or 50 degrees. Notice that angle 2 and angle 3 are vertical angles. So if this happens every time two lines cross, then the vertical angles are supplementary to the same angle. Therefore, we could say with certainty that all vertical angles are equal. Now, complementary angles are angles whose sum is 90 degrees. Therefore, complementary angles form a right angle. And like in supplementary angles, we could say that if two angles are complementary to the same angle, then the two original angles must be equal. For example, if angle 1 is 25 degrees, then angle 2 is 65 degrees, because they are complementary. Now, if angle 3 is also the complement of angle 1, then angle 3 must be 65 degrees also. Okay, so far we noticed that when two lines cross, they form four angles. These angles could be said to be supplementary when they are adjacent on a linear pair, or congruent when they are vertical. Now, if only one of the four angles is a right angle, or 90 degrees, then the other three angles are also 90 degrees. This is the proof we did back in chapter 1.